Okay, well, if we could expand a logarithmic expression using our properties, we can also go the other way. That is, if we have a logarithmic expression written as a sum or difference of a bunch of logarithms, we can usually rewrite that, as long as the bases are the same, into a single logarithm. So let's work on that right here. If I use my rules here, I want to rewrite the logarithm base 5 of x plus the logarithm base 5 of z minus 3 times the logarithm base 5 of y as a single logarithm. Well, one thing I can undo right away is this exponent here, this multiplier of 3. By our rules, this is the same thing as a logarithm base 5 of x added to the logarithm base 5 of z minus, if that exponent is reversed, right, we reverse the rule, we write it as the logarithm base 5 of y to the third. All right, so now we could reverse, and let's use one rule at a time. I've got this addition in my first two terms, so let's combine those together, and we can call this the logarithm base 5 of the quantity x times z, and we're subtracting from that the logarithm base 5 of y to the third. Any more rules? Well, yes. Right, this is a quotient, and so when we combine all of these things together, we have the logarithm base 5 of the quotient, x times z, divided by y to the third. And that would be our single logarithm expression in this particular case. All right, how about something like this next rule? It looks kind of awful. Well, yes and no. In fact, it's actually pretty easy if we remember. Just like in most algebraic expressions, what you should try to do is work from the inside to the outside. So let's work from the inside to the outside right here and just concentrate on these two terms inside of our brackets. We've got the natural log of 2 plus the natural log of the quantity x plus 3, and if we combine those together, we're going to get a natural logarithm of 2 times the quantity x plus 3. Now don't forget that that whole thing is multiplied by the fraction 1/2. So what could I do with that? Well, as a multiplier, it can become an exponent, so that we're actually taking the natural logarithm of the quantity 2 times x plus 3, all raised to the power 1/2. So what could I do with that, if anything? Well, probably nothing else as far as combining these two, but I might recognize that that 1/2 exponent is really a root. And so in fact, I'm taking the natural logarithm of the square root of the quantity 2 times x plus 3. And if I was writing this out, this is the way I might actually write this answer as a single logarithm. And so I'm done with it. Okay, what about our last example? Looks like there's a bunch of different little things going on here. In fact, yes, we've got these multipliers that are nothing more than exponents. So we should rewrite those in exponent form before we do anything else. So what have we got here? Looks like we've got the common logarithm of x squared added to the common logarithm of y to the 1/2 power minus the common logarithm of z to the third. Well, what does that become? Well, use our addition rule next. We can combine our two expressions right here to make it a logarithm, a common logarithm of x squared times y to the 1/2 power. All of that we're subtracting from the logarithm of z cubed. And so we can use our quotient rule here to rewrite this one more time. And it's going to look like this. The logarithm, the common logarithm of the quantity x squared y to the 1/2 power, all divided by z to the third power. And that would be my simplified expression for my last example right here. All right, some more stuff to come.